Hi everyone. In this video, we are going to cover trigonometric substitutions. Before we go to examples, let's study this table. If the expression in the integral is like a squared minus x squared under the square root sign, then the substitution you're going to use is x equals to a sine theta. This is the arithmetic you need to do, we're going to see in the examples, and your simplified radical will turn into a cosine theta. If the expression is a squared plus x squared under the radical sign, then the substitution you're going to do is x equals to a tangent theta. And simplified radical will turn into a secant theta. If the expression is like x squared minus a squared under the radical sign, then the substitution you're going to use is x equals to a secant theta. And simplified radical will be a tangent theta. Let's go to examples and see in detail. Example 1. In the example 1, our expression looks like a squared minus x squared. So a squared minus x squared is a sine theta substitution. So here our a is 6 squared minus x squared. So our a is 6. So let x be equal to 6 sine theta. So what is the x? The x is the derivative of 6 sine theta, which is 6 cosine theta d theta. And here my recommendation is to solve for theta and draw the right triangle. So here our x is 6 sine theta. So sine theta equals to, divide both sides by 6. So x over 6. And sine function is opposite over hypotenuse. So our theta is here, opposite is x, hypotenuse is 6. So from the Pythagorean, this is right triangle, we can find the missing side, which is 36 minus x squared. We're going to need this triangle in the end. And theta, let's solve for theta as well. So sine theta is x over 6. So theta will be equal to arcsine or sine inverse x over 6. If you multiply both sides by sine inverse function, you get theta equals to sine inverse of x over 6. Okay, so after you did necessary substitutions, you can start your question. Now we're going to substitute all x's with 6 sine theta. So instead of x squared here, we're going to write 6 sine theta squared. And in the bottom, we have x here. So we're going to substitute it with 6 sine theta as well. And square. Instead of the x, we're going to substitute the x here, which is 6 cosine theta d theta. Now let's square both x's. So 6 sine theta squared is 36 sine squared theta. And we have 6 cosine theta here on the top, and d theta on the top as well. And here at the denominator, we have 36 minus 6 sine theta squared is 36 sine squared theta. equals to. Now we can factor out 36 here. And what is left inside is 1 minus sine squared theta. And on the top, everything else is there. 36 sine squared theta times 6 cosine theta d theta. At the next step, this is trigonometric identity. 1 minus sine squared theta is the Pythagorean, which is equal to cosine squared theta. So what is left in the bottom is, under the radical, 36 cosine squared theta. And on top we have 36 sine squared theta, 6 cosine theta. Square root of 36 is 6. Square root of cosine squared is cosine. So we can take this expression out of radical sign. And on top we have 36 sine squared theta times 6 cosine theta and d theta. Here 6 cosine theta cancels out 6 cosine theta, and we are left with 36 sine squared theta. We can take the 36 to the front, so 36 sine squared theta d theta. After this point, you're gonna attack the integral. Use all your knowledge, all your integration skills and techniques. So here sine squared theta, we can apply here half angle identity. So what was the half angle identity for sine squared theta? So sine squared of theta, or sine squared of x, equals to 1/2 times 1 minus cosine of 2 theta. So we can substitute sine squared theta with 1/2 times 1 minus cosine of 2 theta. So 36 integral 1/2 times 1 minus cosine of 2 theta. d theta. Here we can take 1/2 to the front, so 36 over 2 1 minus cosine of 2 theta d theta. And if we simplify, it's going to be 18 integral 1 minus cosine of 2 theta. Now we can take the antiderivative of each expression here. So antiderivative of 1 with respect to theta is theta. So 18 times theta minus antiderivative of cosine is sine. And we have 2 theta here, which is the chain rule, and our correction factor is 1/2. So 1/2 sine of 2 theta plus c. You can also test out 1/2 times sine 2 theta. If you take the derivative of 1/2 sine 2 theta, it has to give you back cosine of 2 theta. So let's take the derivative. So 1/2 is the constant in front. The derivative of sine is cosine of 2 theta, and inside function chain rule times 2, and 2 cancels out 2, so we end up cosine 2 theta. So derivative of 1/2 sine 2 theta gives us cosine 2 theta back. So antiderivative of cosine of 2 theta is correct. And here the practical method is take the antiderivative of the cosine function, which is the trigonometric function, and multiply it by the correction factor. 2 theta, correction factor is 1/2. If it was 4 theta, correction factor is 1/4. Okay, so let's clean up. 18 theta minus 1/2 times sine of 2 theta plus c. Here we know what theta is, what we did at the beginning. We solved for theta, but we don't know sine 2 theta, so we have to rewrite this. We can use double angle identity. So sine of 2 theta equals to 2 times sine theta cosine theta. So we can rewrite sine 2 theta as 2 sine theta times cosine theta. Let's do it. So 18 times theta minus 1/2 times 2 sine theta cosine theta. Here 2's cancel out. So 18 times theta minus sine theta cosine theta. Now we have to put theta in terms of x. So we solved for theta. Theta was arcsine of x over 6. And we need to find cosine theta. Now we have to utilize the right triangle. So here cosine is adjacent over hypotenuse. Adjacent is radical 36 minus x squared, and hypotenuse is 6. So let's go back and write cosine as well. So 18 times, instead of theta, we're going to write arcsine x over 6 minus sine theta is opposite over hypotenuse, which is x over 6, times cosine theta was adjacent over hypotenuse, which is radical 36 minus x squared over hypotenuse plus c. Let's reduce, clean up, and simplify. 18 times, let me write arcsine in condensed form. Arcsine of x over 6 minus x 36 minus x squared over 36 plus c. You can leave your answer here. So this is the final answer. Let's go to example 2. In this example, our expression is x squared plus a squared. So whenever we have x squared plus a squared, or opposite a squared plus x squared, because addition is commutative, then our substitution is a tangent theta. Here our a is 2 because 2 squared is 4, so 2 tangent theta. But the coefficient of x is not 1 here. The coefficient of x is 25. So we're going to make 5x equals to 2 tangent theta. Square root of 25 is 5. And if we solve for x here, our x will be 2/5 tangent theta. If x is 2/5 tangent theta, what is the x? The x is the derivative of this, which is 2/5. Derivative of tangent is secant squared theta d theta. Let's solve for tangent theta. So if we multiply both sides by 5/2, then tangent theta equals to 5x/2. And let's also solve for theta. So theta equals to, if we multiply both sides by tangent inverse, so theta will be arctangent of 5x/2. And let's draw our right triangle. This is our theta. If tangent theta is 5x/2, tangent is opposite over adjacent. So opposite is here, 5x, adjacent is here. And from the Pythagorean identity, we can solve for hypotenuse. And the hypotenuse will be 25x² plus 4. So this is the ingredients we're going to utilize throughout this question. Now let's substitute all x's with 2/5 tangent theta. So integral equals to radical sign. We have 25. Instead of x squared, we're going to write 2/5 tangent theta squared. And we have 4 here. Instead of x to the 4th, again, we're going to write 2/5 tangent theta raised to the 4th power. And instead of dx, we're going to use dx here, which is 2/5 secant squared theta d theta. Now let's do necessary simplifications. So on top, we have 25 times 2/5 squared is 4/25, and tangent squared is tangent squared theta. We have plus 4 here, and 2/5 raised to the 4th power is 2 to the 4th power is 16, 5 to the 4th power is 625, and this is tangent 4th of theta. And we have dx here, which is 2/5 secant squared theta d theta. Okay, here 25's cancel out, and if you factor out 4, we end up with tangent squared theta plus 1 divided by 16/625 times tangent 4th of theta. And we have dx here, which is 2/5 secant squared theta d theta. Here, tangent squared theta plus 1 is the trig identity. So this expression equals to secant squared theta. So this is secant squared theta. And if we take this outside of the radical sign, square root of 4 is 2. Let's write integral sign first. Square root of 4 is 2. Square root of secant squared theta is just secant theta. And 16 over 625 tangent 4th power theta 2/5 secant squared theta d theta. Okay, let's simplify all the numbers. Here 625 divided by 5 is 125, and okay, this is 125. 16 divided by 4 is 4, and we can take this outside of the integral sign. So 4 over 125. One over 4 over 25, because 1 is on top, 4 over 25 is on the bottom. Okay, so trig functions, secant theta is left here, times secant squared theta d theta, and on the bottom we have tangent 4th of theta. Let's clean up here. 1 over 4 over 25 is 125 over 4. And secant theta times secant squared theta is secant cube of theta. And we have tangent 4th on the bottom and d theta. Now we're going to write secant and tangent in terms of sine and cosine. So 125 over 4 is in front. Secant is 1 over cosine, so 1 over cosine cube of theta. And tangent is sine over cosine. Sine 4th theta over cosine 4th of theta. D theta. Here, cosine cube and cosine 4th cancels out. We leave here only one factor of cosine. So 1 over sine 4th of cosine theta, which is cosine theta over sine 4th theta. Here we can rewrite cosine and sine like this. We have 125 in front, 125 over 4 integral. We can rewrite this as 1 over sine cube of theta times cosine over sine. We have 4 factors of sine in the bottom, and we have 1 factor of cosine on top. One over sine is cosecant, so it's going to be cosecant cube theta, and cosine over sine is cotangent. Now we can integrate this function by using u substitution. So let's use different letter. Let w be equal to cosecant theta. So dw, which is the derivative of cosecant theta, will be negative cotangent theta cosecant theta d theta. Okay, so let's do the substitution here. So 125 over 4. So this is going to be w cubed times cotangent theta. And instead of d theta, we're going to write d theta is here, dw over negative cotangent theta cosecant theta. So we can pull the negative sign to the front, and cotangent theta, instead of cosecant theta we can write just w. So cotangent cancels out and we are left with, let's continue here, negative 1/25 over 4. So w squared dw. Okay, this question bulged example 3, but we can use this space. So how can we take the antiderivative of this function? Antiderivative of w squared is w cubed over 3, because we add 1 and we divide by the power, plus c. So now we have to bring w back. So negative 125, we can multiply these two numbers over 12. Instead of w, what was w? W was cosecant theta. So we're going to write here cosecant theta and cube. So cosecant cube theta and plus c. But we have to convert theta in terms of x because we have to solve for x. Okay, so cosecant theta, we're going to pull up it from our right triangle. So cosecant is 1 over sine, which is hypotenuse over opposite, 25x squared plus 4 under the radical sign over 5x. So cosecant is this, hypotenuse over opposite. Let's rewrite. So we have negative 125 over 12 in front, and our cosecant function is hypotenuse over opposite, which is 25x squared plus 4 over 5x cubed plus c. Okay, let's clean up a little bit more. So 125 over 12 times 25x squared plus 4 cubed. 5x cubed is 5 cubed is 25, x cubed is x cubed, and they cancel out here. So we can write it as 25 x squared plus 4 cubed over 12x cubed. So this is our final answer. You can leave it here. And we should not forget the negative sign and plus c. Example 3 is our last example for this video. In this question, our expression is x squared minus a squared. Whenever you have x squared minus a squared, your substitution has to be a secant theta. Here our a is 4, a squared is 16. So our x equals to 4 secant theta. So what is the x? The x is the derivative of this, which is secant theta tangent theta. Here let's solve for secant and construct our right triangle. So divide both sides by 4, so secant theta is x over 4. Let's construct the right triangle. So if secant theta is x over 4, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant theta will be hypotenuse over adjacent. So let's call here theta. So hypotenuse over adjacent. So from the Pythagorean identity, we can find the missing side. Missing side will be x squared minus 16. Okay. So here in the question, we are going to substitute x with 4 secant theta. Let's begin. So integral 1 over, we can rewrite this as 3 over 2 exponential form and get rid of radical sign. So instead of x squared, we're going to write 4 secant theta squared and we have negative 16 here. And instead of dx, we're going to write 4 secant theta tangent theta. D theta. Okay, let's clean up a little bit more. So 1 over 4 secant theta squared is 16 secant squared theta minus 16 raised to the 3 over 2 times 4 secant theta tangent theta. Here we can factor out 16. So what is left inside is secant squared theta minus 1. And we have 1 above, and we have dx here, which is 4 secant theta tangent theta. This is Pythagorean identity. Secant squared theta minus 1 equals to tangent squared theta. Now let's raise it to the 3 over 2. 16 raised to the 3 over 2, so we can convert the radical sign to understand better. So 16, square root of 16 is 4, and 4 cubed is 64. and square root of tangent squared is tangent, and cubed is tangent cubed theta. So let's write better. So integral 1 over 64 tangent cubed theta, and we have 4 times secant theta tangent theta d theta. So 4 and 64 simplifies to 1/16, and we can pull it to the front. One factor of tangent goes here, so we have 2 factors of tangent and secant on top. So secant theta over tangent squared theta is left. Now let's write secant and tangent in terms of sine and cosine. So 1 over 16, secant is 1 over cosine theta, and tangent is sine over cosine. If we simplify, we can do keep, change, flip. So cosine cancels one factor of cosine here. So we are left one over cosine over sine squared, cosine theta over sine squared theta. Here what we did is keep, change, flip. 1 over cosine theta times cosine squared theta over sine squared theta. And cosine cancelled out one factor of cosine above. So cosine theta over sine squared theta is left. Now we can use u substitution to take antiderivative of this integral. Let's use different letter. Let's use w. Let w be equal to sine theta. So dw, which is the derivative, will be cosine theta d theta. Okay, let's substitute. So 1/16 integral cosine theta over, instead of sine squared theta, w squared, and d theta here equals to dw over cosine. So dw over cosine. So cosines cancel out. So what is left is 1 over w squared. And we can take w squared to the above as the negative power. Now we can take the antiderivative of w raised to the negative 2. So we're going to add 1 and divide by the power plus c. So 1/16 times negative w to the negative 1 plus c. And this will be negative. We can pull negative to the front, and it's going to be 1 over w. Let's bring w back. W was sine theta, so negative 1 over 16 sine theta. And we have to write sine theta in terms of x. So we have to utilize our right triangle. So sine function is opposite over hypotenuse. So radical sine x squared minus 16 over x. Since it's 1 over sine, so it flips. So it's going to be hypotenuse over opposite. So negative. Hypotenuse was x. And opposite was x squared minus 16. So this is the final answer. And let's not forget to put plus c. Thank you for watching. See you at the next videos.